Hi everyone. I prepare a small presentation so that it is not very formal, but I thought, let's have something before I can able to show the code. In this, whatever the demo I'm going to show, it is mostly focused on time series based on the deep learning. There is a three types of time series model we can predict using a deep learning. The first one is single step. What that means is you give one time input and then you get one output time in futuristic time, right? If you're assuming that you give previous day weather and then you're predicting next day weather, only one step, okay? And then there is a multi-step model. What it does is you give many timestamp, like assuming that you give last 30 days data and then you are predicting one day, 31 day, right? What that means is in the future you are expecting one, right? Because here a time step, I am assuming that it is a day. It can be 20 minutes, it can be 10 minutes, it can be anything, right? It is basically each iteration, each data representation is nothing but a time step, okay? Next is multi-output model. What this one is, we are going to predict many variables, right? What that means is you can in in the past, right? You give an input many timestamps. It can be 15 days, it can be 14 days, it can be 1 week or anything like that. But you are predicting for future for as many, like for example, you want to predict 7 days, right? But not only single target. Single target means assuming that you want to predict for rainfall, you want to predict for precipitation, you want to predict for rain, river dispatch, anything like that. You can have as many columns you want, right? Today, whatever the things I've done is based on the model 3. It is called multi-output model. It is basically, you can also say uh, very high level. This is the DNN model, okay? Deep neural network model, okay? There is a two models are there. One is linear model. Linear means you sequentially will move it, right? Then what happens is when you have a sequentially, there is no hidden layers will be there. If there is no hidden layers, your formula or your whatever the machine learning model is doesn't understand everything for you, right? It is going to be more linear. It can be, you can think like a linear regression or logistic regression, something like that. It has some formula and then based on that something it does, right? But when you do deep learning, it calculates the formula for you, right? It builds the formula for you. It understand everything, and then how many hidden layers you put it, and then it is a dense layer. This is it understand, and then data input data, based on that it builds the model, builds the formula for you. You don't have you don't need to know what is the formula is, right? That's a very high level, okay? Another important concept in the any time series model, when you pull the data from CSV or anything like that, you had to make it as an index column as a date time. Every time even though you save the data into CSV, before saving the index column might be date and time, but once you save it, you lose that behavior. It saves as a string, right? Again, you load it, you treat it as a string. Every time you need to parse the data, right? You need to parse as a date and time, right? It is basically you are treating that index column as a date and time, and then you are converting in that. When you are doing like any machine learning model, right? If you convert into this format, it identifies right way and then it gives the results. Otherwise, it doesn't work. Technically speaking, with the time series, if we don't convert it, it doesn't work, okay? Very high level key concepts are whenever we are doing deep learning, even though you have a 1,000 records or 5,000 records, but we had to divide the data into the small batches, right? The small batch is nothing but a data windowing. You need to decide that what is your window size, right? Though that is the window you are giving as an input. It can be 7, it can be 10, it can be any number, right? In this case, in this diagram, it is 24. It is basically hourly data, and then you are giving us 24 hours data, and then you are predicting next 24 hours, right? Basically, that's a prediction. This one input is nothing but what you are giving. Output is what it is predicting, okay? Next is a concept two is whenever you have so much data, you need to prepare multiple batches, any number of batches, right? Batch one contains here 32 windows, right? Uh, Basically 32 batch size, right? What that means is window one, window two, window three, right? Each window contains 24 steps. If you think here, window is 0 to 23, right? 23 means it's starting, that means that 24 steps, that is one window, right? Data window. Now we have a 32 data windows. That's like that you divide, right? If you have how much data you have, assuming that you have 1,000 records and then each data window is 10, that means that you are going to have 100 batch size is 100, right? 100 data windows. Okay, that is very high level. If you understand, that is good enough. Now what I will do is the next step is I will go, if somebody wants to learn, right, TensorFlow or time series, just Google it, just like if you go here, time series, TensorFlow, you just search it. If you click here, this is the link it is going to show. Okay, this is the link it shows. Okay, even if you go here, this is a link it shows. Okay, I'll close here. Now in this link, right, you can run on the Colab, the source code, you can run on the GitHub, right? Here they pick some weather data based on that. They given complete example. Okay, in this example, if I go here, whatever I explain as of now, right, data window, this is 24 windows, right? Then you are predicting for next 24 windows. Basically, here the label is one width. That means that they're only predicting one width, futuristic one. That's it. Now, whatever the class, the main behind this time series is, this is a only class. Based on this, we are doing everything, right? I utilize another textbook called TensorFlow, not TensorFlow, like a time series in Python. This is a textbook I use, time series forecasting in Python. This is the one I followed. The similar thing he explained were pretty much similar, but he used the, instead of window generator, use a data window, right? That's the only difference, nothing else, right? If we can understand this class, right, nothing else is need to know anything time series, right? Very high level, what I will do is I will go to the my code, right? And then I will just simply explain this, right? I imported all the libraries what needed. These things you don't need it. I can able to import as a TensorFlow keras and then it will work. Now, if I go here, I just basically three data sets are there. One is a train, valuation, and test, right? What here I'm doing is, this is, I believe it is 60%, this is 20%, this is 10% of the data. Total, I divided like that. That's where even in that article also mentioned same way, right? Now, this is the class, okay, very high level. What we are doing is we are giving input width, assuming that input width is, my case is 14. I'm expecting 14 days, right? You can give 7 days input, 7 days output you can give. Here the shift is nothing but your how many days in future you are moving, right? What that means is I will show you later what the shift means. Okay. And then I'm passing a train DF and valuation DF and then everything. And then I'm giving a label column. Label column means what are my target columns, right? Assuming that in this our data set, we have a 21 columns. Out of 21 columns, we want to forecast only 6 columns. Those 6 columns we are going to give. These are the simple data. This is a plot. You want to draw the chart, right? This is the one we are using a function. The main important thing here is even though you have a data set, in order to tensor flow to understand, you need to convert the format. This is the one that's where when I call valuation, it calls make data set. This is the data set we are using for predicting the time series. Okay, that's a very high level. Another important thing is baseline. Baseline is nothing but you have the base model, right? What it is predicting. Based on the base model, you are going to compare with other models, right? In this notebook, base model is there. Then I have a dense model, DNN. Then I have a LSTM. 3 models are there. The predictions are very close. It is not much difference. This is a 0.6, I believe, a regular base model. The DNN model, it is predicting, I believe it is a 0.056, right? Then if we go to the LSTM, it is predicting 0.507. It is almost similar, right? The shift, I'm doing shift 1, right? It is figuring out the last digit. It is 30. I believe I'm using 30 here. Just I forgot. Actually, I was thinking it is 14. It is 30. Now what happens? It starts from 0, right? Indexing. Now it is a 29, 30, right? This is one shift I'm predicting, right? This is very high level. Even if you don't understand, right? Offline, if ping me, I can explain. Okay. Now the next thing I want to show you is okay, I will go to my spider. Okay, the entire notebook, right? I convert into the Python file, right? Python extension. What I am doing here is all the code. There is no diagrams. Other than diagrams, everything is put together. I just want to show the feel of the stuff. Okay. Here, what we are predicting at the bottom here is I'll make a smaller. Here is this is my predictions. Okay. I created a data model, data window. I'm passing 14 days input, 14 days. I want to predict. I want to predict after 14 days, right? Then I'm giving what are the columns I want to predict. I gave 6 columns. I'm predicting that, right? What I'm going to do here is I will clear everything, all the variables, everything, right? Nothing is there. I'm going to run it. Now it takes very few seconds because I'm running locally, and then, it requires some settings to basically disable GPU. Some reason in the spider, this variable is not working, OS. I need to set the OS level, and then, there is a min GPU. That option is not working. OS is not working. I thought, okay, that's fine. Okay. Now the results are in place, right? If you look here at the bottom, I just put 2 statements: input indices, label indices, or basically you can say output, right? If you look here, what is my input indices? Input indices, you can assuming is 0 to 13, 14. It is 14 days input data, right? Because index start from 0. If I go my output index start from 14, right? 14 means 15th, right? Basically index start from one number less to 27. That's the prediction we are doing, right? Now, if you look here, my prediction I put in with column names. Without column names, how the data looks like. This is the data it is predicting. Okay. Now with the data frame, with the columns, this is the one it is predicting. Okay. By default, before 263, this is a tensor. Okay. If I show that predicted results, you see here, it has a 507, my total data frame, whatever the test. This is the one which gives the data. But you will confuse what is this 507 and then do the stuff, right? This is the time series magic. If you understand this, then pretty much you can do any problems. This is the only thing you have to understand. Okay. This is what it does. Like what I'm doing here is 14 days prediction, 6 features we are doing. Now, if you do 0 index and then you get this tensor or array, we can say, right? From this array, I am converting into NumPy, right? From NumPy, I'm converting into data frame. From data frame, by default, it is giving indexing 0, 1, 2, 3, right? 6 columns. Now I'm giving a column names, right? Then I'm printing here. That's it. Very high level. That's for a predicting this stuff, right? Now I want, if somebody want to know, then I will quickly go to Streamlit app. Streamlit app, the only main important thing here is this is a file. What I did was that model, LSTM model, I saved H5, or you can do proto buffer, but I use H5. I saved this model and then separately, and then I'm loading the model, right? I'm using a caching so that whenever it calls, only first time it loads and the next time it gives from the memory. Cache data also same thing. I'm loading and test data. And then basically it is simple logic that when you are running the app or weather app, I have a readme file is there. If somebody wants to run, just open in the VS Code, or you can use a PyCharm, just activate and then just install requirement package and run this command, or I just put it here in the Streamlit, and then you can able to see here. Oh, I already logged in. Yeah, if somebody wants to set it up Streamlit app, right? You just log in into Streamlit app, you click new like this, and then you need to have a code in your repository. Just select whatever the repository name, and then you give your branch, and then you give the file where it is looking, and then you click deploy. You need to give the name, what name you want, and then deploy it, and then it will be available for you. Okay. I'll just copy, and then once whenever you do any changes in the code, right, you just reboot it. Just now I did, and then so you don't have access to this app. It doesn't exist. Okay, something happening, right? Okay, I'll just close all the. Okay, any questions? And then before I'll close all this. I stop.